So remember, if my function is 1 to 1, then it has an inverse. And also remember that with inverses, too bad I couldn't spell that, the coordinates simply switch. So in other words, that does say inverse. So in other words, if the function has the point a comma b, then f inverse has the point b comma a. That's important. So here, if I know f of 2 is 9, so that means for f of x, we have the point 2 comma 9, because 2 would be the x and 9 would be the y value. So for f inverse, oops, over here, why am I calling it f prime? I meant inverse. I said inverse, I just didn't write that. So f inverse would have 9, 2. So when it asks, what is f inverse of 9? Oh, it's 2. Simple enough. So on this one, I want to graph them both. Keep in mind that they are going to be symmetric about y equals x. So if I put this in here, that should be the mirror. And I'll probably want to generate some points. So if I look at the table for f of x, and I plug in some values, so if I plug in, let's say I plug in -2, we'll do -2, -1, 0, 1, and 2, because I might not have that memorized exactly what it looks like. So of course making a table is one way to find out. So if I plug in -2, I'll get -8 plus 1, which is -7. If I plug in -1, I'll get 0. If I plug in 0, I'll get 1. If I plug in 1, I'll get 2. And if I plug in 2, I'll get 9. So I could plot these. So -2, 4, 6, 7. And it'll look like that. And then for f inverse, remember all that really happens, all that I really have to know to do, I don't even need to write the equation, is the x's and y's switch. So I can just list them out and then go plot them. And so what you should notice, turn head sideways a little, is that they are in fact mirror images across y equals x. So of course to find f inverse, remember I have to switch x and y and then get y by itself. So I'm going to subtract the 1 and then I'll cube root. So the cube root of x minus 1 is my new function. And I'm going to name him f inverse. So there's the equation. I have the graph. All done. So in this one, if I use the derivative, I can determine, based off of this slope, if it's strictly monotonic or not. So I'm going to set it equal to 0 and figure out what those x values are that are going to divide it up. And so remember all the way back to chapter 2 where we were doing this. And so something's happening at 2, I'm not sure what, so I'll try some values. And if I find the slope using 0, turns out positive. If I find it at 3, turns out positive. So increasing, increasing. Since it's increasing everywhere, it's strictly monotonic, which then means it has an inverse. And they didn't even ask me to find it. Okay. All right, see you tomorrow.